Welcome to this explainer. Today, we are going to tear down a really complex, real-world architectural triad that powers an incredibly advanced local AI web scraping workflow. We're going to pop the hood on a system that brings together automation, structured web data, and massive local language models to solve a highly specific, real-world problem. And honestly, the way these three tools talk to each other is absolutely fascinating. So let's just dive right into it.
You know, oftentimes when you hear the word drop shipping, your red flags immediately go up, right? You're probably bracing yourself for some cheesy pitch on a shady online wealth course. But we're completely flipping the script today. We are going to use local AI and advanced web scraping to completely expose drop-shipped markups, directly linking a highly marked up Amazon product straight back to its original source. Basically, we're using these advanced tools for good.
So here is our roadmap for today. 1. The local AI bottleneck. 2. Orchestrating the web layer. 3. The three-node smoke test. 4. The dropship detector logic. 5. Overcoming hostile web scraping. And finally, 6. The vision model verdict.
All right, Section 1, the local AI bottleneck, why raw web scraping chokes local models.
It all really comes down to the context window. This is the maximum amount of text, code, or data that a local AI model can hold in its working memory at one time without just failing or completely hallucinating. We're actually using the Qwen 3.635 billion parameter model locally on a laptop for this. So if you're troubleshooting resource constraints during local model inference, this right here is your primary suspect. Feeding a massive model raw, messy website code and asking it to navigate autonomously, that will instantly choke its memory out.
So what's the fix? Well, the solution is all about formatting. Unstructured web data means massive HTML files, incredibly fragile scripts, and a bloated context window. Structured JSON data, on the other hand, is clean, lightweight, and highly efficient. If we want the AI to do the heavy reasoning, we absolutely must feed it structured JSON. We just can't force the AI to do the messy scraping itself.
Moving on to Section 2, orchestrating the web layer, the architectural triad.
To solve that context bottleneck, we're assembling what I like to call an architectural team made up of 3 distinct tools. First, we have the brain. That's our local Qwen 35B model executing the heavy logic. Second, there's the scout. We're using OxyLabs as our web layer here. OxyLabs goes out, finds the unstructured web data, and packages it up into that beautiful structured JSON we desperately need. And finally, the nervous system, NA10. NA10 is the orchestrator that flawlessly pipes those structured JSON payloads from OxyLabs directly into our local AI. They work together as this perfect, cohesive unit.
Section 3, the three-node smoke test, proving the JSON schema pipeline.
Okay, let's walk through how this actually flows in a simple proof of concept. Step 1, an N8N manual trigger kicks off the workflow. Step 2, OxyLabs performs a basic Google search for our target creator, B. John Bowen, and hands back structured data. Step 3, our local Qwen model ingests that structured data and generates a strict JSON summary. This little test just proves the orchestration is solid before we scale up to the complex stuff.
Now, looking behind the scenes, the technical configuration for this local environment is pretty slick. Because N8N is running inside a Docker container, it uses host.docker.internal to successfully route data out to your local Ollama server on port 11434. And to enforce the JSON schema structure for model communication, the model gets incredibly strict instructions to return, quote, JSON only. This seamlessly transforms that OxyLabs data into a perfect, clean summary, completely dodging the context bottleneck.
All right, Section 4, the dropship detector logic, automating the search for the source.
Here is where the logic just beautifully comes together. Step 1. A webhook triggers NNN, and OxyLabs scrapes the specific Amazon product ID, handing back clean data. Now, Step 2 is where the magic really happens. The local AI autonomously analyzes the terminology in the Amazon listing and builds a custom search query specifically tailored for AliExpress. A massive best practice here is letting the LLM dynamically generate these custom API queries within the NNN workspace based on the structured data rather than you trying to hardcode them. Then, in Step 3, NNN feeds that dynamic AI-generated query straight back to OxyLabs.
Section 5, overcoming hostile web scraping, parsing complex retail sites.
Let's be real. AliExpress is a notoriously hostile layout for web scraping. It is just packed with new user pop-ups and incredibly messy, unrelated page data. Because pulling candidate images from this kind of chaos is super fragile, the N8N workflow has to utilize rigorous fallback logic.
If an image link breaks or a parsing failure happens on these complex retail sites, the workflow catches the error and continues gracefully rather than just crashing the whole operation.
And finally, Section 6, the Vision Model Verdict, AI Image Comparison in Action.
So, for the final challenge, we are relying on a 35 billion parameter vision model running directly on consumer hardware. NN prepares a highly specific data payload containing the scraped images from both platforms. The local AI logic is configured to perform a direct, side-by-side comparison to determine if these are the exact same OEM or original equipment manufacturer product.
And here is the exact verdict it spit out, generated autonomously by the local AI. Strong visual evidence confirms the Amazon listing is the exact same physical product as the AliExpress candidate. The local AI came up with this conclusion entirely on its own, after navigating that whole automated NN pipeline. I mean, that is just incredibly powerful.
The Qwen model actually returned a 95% confidence score based on some amazingly specific logic. It detected an identical fan configuration, it matched the honeycomb mesh pattern on the surface perfectly, and it even noted that the generic logo was positioned in the exact same top right corner. It is wild. This just goes to show how robust local vision models really are when you feed them clean, structured data.
So, let's look at the final math here. The Amazon price was $25.18. The AliExpress source price that the AI found was $17.91, uncovering a markup of about $7.27. And remember, the architecture exposed this entirely autonomously. No human ever needed to open a browser or parse a single line of HTML.
I want to leave you with this really provocative thought. If a local AI running right on a laptop can autonomously navigate hostile, complex retail sites to expose hidden pricing tricks, what other hidden web data could you uncover using this exact trifecta of NN, OxyLabs, and local AI? The possibilities for automating truth and uncovering hidden data are absolutely massive. Thank you so much for joining me on this explainer, and keep exploring out there.